All right, so thanks a lot for making it out to the first session of the day. In this session, I'm going to be demoing taking a simple Angular 1 app and migrating it over to Angular 2. I'm not going to focus a lot on why you might want to use Angular 2. I'm going to focus more on the how. But just to give you a little bit of context, if you're not familiar with Angular 2, it's a total rewrite of Angular 1. So it is able to get rid of a lot of the old concepts in Angular 1 that are sort of redundant and don't really make a lot of sense anymore today. And it really takes advantage of a lot of modern web standards. So, ECMAScript 6, TypeScript, web components, Shadow DOM, RxJS. You can really take full advantage of all of these technologies. And Angular 2 is also really fast. So you can do things like server-side rendering in Angular 2 or running Angular inside a web worker, which is just going to make it a whole lot faster. So there's a lot of reasons you might want to migrate to Angular 2. But if you have an existing Angular 1 app, how might you actually do that? So the Angular team actually released a library called ngupgrade. And what this lets you do is actually run Angular 1 and 2 together in the same application. So you can take an Angular 1 service, kind of upgrade it into an Angular 2 service, and then inject it into an Angular 2 component. And this ngupgrade is sort of the middleware layer that lets you translate between Angular 1 and Angular 2. But before we can jump right into actually migrating an Angular 1 app to Angular 2, first there's a lot of work you have to do to sort of prepare your app to be migratable to Angular 2. And a lot of these are really just best practices. So if you're already following them, then you're already going to be in a really good position to migrate to Angular 2. But if not, this is where the bulk of your work is going to be. So I think there's actually a bigger difference between sort of poorly written Angular 1 and well-written Angular 1 versus well-written Angular 1 and Angular 2. So once you follow these best practices, migrating to Angular 2 is actually going to be pretty simple. So the first thing I wanted to talk about is $watch. So this is a feature that gets used a lot in Angular 1, but there's actually very rarely a good reason to use this. And it's something that doesn't even exist in Angular 2. So if you can start avoiding using it now, it's really going to help you when it comes time to migrate. So I've got a really simple example here. We just have an input that has an ng model, and then we're watching that model in the controller, and whenever it changes, we're going to parse it as a moment and then try and format it, and then we'll output the formatted date here. So it would just look something like this. So I can just type in any date, and it's going to, there we go. It's going to try and format it as a date. So I've implemented that using $watch. As you can see here, I'm using $watch. But there's a lot of different ways I can do this that are actually better. So some of the issues with $watch is that it's not declarative. So the big advantage of Angular 1 and one of its core principles is that it's declarative, and it lets you sort of read through the HTML and have a good understanding of what the app can do. But the way I've written this, there's no way you can look at this HTML and have any idea that changing this, the text in this input is going to have any side effects. It's totally hidden somewhere in some function somewhere. So it's going to be kind of hard to track down. And it's also inefficient. So using scope.watch actually creates a new watcher, and this watcher will be called every time anything changes anywhere in your app. So this function here is just going to get absolutely hammered. So another way we could have written this without $watch is to use ngChange. So in this example, I've just put an ngChange on the input, and it's calling this function on my controller. And on my controller, I'm doing that same formatting of the date. And this may not look very different. I mean, I'm kind of doing the same thing. I just have a function that updates that date whenever it needs to change. But now you can look at the HTML and actually have a pretty good idea of what's going to happen, because you can see that this ngChange is registered. And also, this isn't adding another watcher. This is just going to listen to the DOM events on this input element and only call that function when it absolutely needs to be called. And we can actually take a look at that. So here's the example I had using $watch. So if I run this little tool called ngStats, which is just a little bookmarklet that can give you some stats on your Angular 2 app, maybe a little bit hard to see, but it's showing the number 3 right here. So it's telling me that I have 3 watchers on this page. If I load up the same solution but using ngChange, you can see that now I only have 2 watchers. So obviously, the difference of 1 watcher is not going to make a big performance difference here, but in a bigger, more complex app, limiting the number of watchers or having too many watchers is the root cause of most performance problems in Angular. So you can kind of solve that partially by avoiding $watch. So there's actually a whole bunch of different ways we could write this, all without using $watch. We could use ngModel options getter setter. And what this does is it takes your model and uses it as a getter setter function. So you can see my model now, instead of just being a string, it's actually a function that sets this internal underscore raw date or gets it. And this way, I have a function that gets called whenever this changes, so I could update the date string whenever it gets changed. Another way you could do it is just with a function. So you could just create a binding to a function that goes and gets you the date string whenever you need to update it. So there's a whole lot of ways you could do this. You could use a filter, you could use formatters and parsers. You really don't need to be using $watch. So I created a sample app that I'm going to be applying all of these best practices to as we go. And it's up on GitHub if you guys want to check it out later. Let's see, so it's right here. And I have a different branch for every step I'm going to go through. So you can see the first step here is going to be removing watch. And then we're going to have a bunch of other steps. And all the app is just this simple image sharing app. So we have a list of images. You can add new ones here. So if I add an image, test, it's going to upload this image. It might be kind of slow. Or, yeah, I may need to restart. Oh, there we go. Yeah, it's just a little bit slow. So that's a sample app. We can take a look at the code for it. It's pretty basic. We just have our root app here, which is using the Angular 1 router. It's setting up a route to this image list controller. The image list is kind of the main bulk of the app. It's where we have our ng-repeat that shows all the images, and it just includes a directive for that modal you saw. So then I've got the modal registered here. And you can see that the modal is using $watch right now. So what it's doing is whenever show modal gets set to false, we want to clear out the URL and description. But the only place show modal is ever set to false is in this function here, and again in the HTML. So on this ng-click, I'm setting show modal to false. So I could quite easily just call a function there that handles everything that needs to happen instead of unnecessarily creating a watcher. And if we take a look at the changes in my version control, you can see that's pretty much what I did. So I replaced the $watch on the left with just a close function, and then I can call close whenever I want to close. So when you submit the form, it's going to call close. And in the HTML, when you click the button, the cancel button, it's also going to call close. So that's just one simple way we can avoid using $watch. All right. So just to review, it's good to avoid $watch because it makes your code pretty hard to reason about. It's pretty hard to follow the flow when you just have to know where these $watches are being registered and worry about the order they're being executed in and what happens in the edge cases when undefined gets passed in and stuff like that. They're not declarative, so you lose a lot of the readability that you normally get from Angular. They're bad for performance, and you can't use them in Angular 2. So just a lot of reasons to try and avoid using them in your current Angular 1 code. Another really important feature of Angular 1 I wanted to talk about was isolate scope. So right now, my image modal directive is a child of the image list, and it's not using isolated scope. So everything is just on the exact same scope. So when I want to show and hide the modal, I'm just setting this show modal, and that's the same thing that the image list would set. And if I want to submit an image, I'm calling scope.upload new image. Well, that's a function on the parent controller, so on the image list controller. And this is, not great because I have absolutely no encapsulation. Everything is essentially on the global scope, and there's really no point of even creating a custom directive. It just makes it look like things are encapsulated when really they're not, and it's just going to kind of hide what can possibly change things. So we can solve this by using isolated scope. So you use isolated scope just by adding in a scope to your directive. And this is obviously going to break the code right off the bat because I can't access show modal anymore or upload new image. Now, one way that people sometimes get around this is to use scope.$parent, which will get you up one parent scope. But this kind of defeats the purpose of using isolated scope in the first place because now I'm just back to accessing things directly on the parent. And I'm going to come back to parent in a minute and see some other reasons why you don't want to use it. But a better approach is to actually specify the variables you want to pass into your directive in the isolated scope. And then when you're actually using this directive, like how we're using it here, we just have to pass in the mapping of what we want those variables to be. So isolated scope is great. It lets you use encapsulation, lets your components be much more isolated and easy to understand because they don't have a bunch of external things affecting them. Much easier to unit test, and it's pretty much how components work in Angular 2. I mean, the notion of scope isn't really there anymore, but if it were, it would be an isolated scope. It's much more analogous than using a global scope in Angular 1. The controller as syntax is another really great feature in Angular 1 that's going to help you migrate to Angular 2. Before I start using it, I just wanted to show a quick demo of when it's going to come in handy. So let's check this guy out. Okay, so in the same modal I've been looking at, it has an ng-show that is showing and hiding the modal. Now, if I change this to an ng-if, you wouldn't think that that would really change anything. But if I reload the page, which might be kind of slow, or my internet's not working. Let's make sure I'm actually running a server. Looks like I'm not. Okay, HTTP server. I'll just disable caching. Okay, let's give this a shot. So now if I try and add an image, and I submit this, nothing's actually going to happen. And so just changing that ng-show to ng-if broke my whole app. So how is that really possible? So what's going on here is a weird sort of edge case of how prototypical scope inheritance works, and it's pretty complicated. But basically, you've probably run into this issue before because it's a really common issue that everyone runs into in Angular. When you have an ng model and you bind directly to something on your scope, what happens if there are sort of multiple scopes that are inheriting from each other is when you set the ng model, it's going to set it on the inner scope and essentially create a separate variable than what was on the parent scope, and now you'll have two different versions of URL. So in the controller, when you try and submit URL, you're going to be getting the old version of it, or it'll just be an empty string. And I can kind of prove that that's what's going on. If I change this to parent, and we'll do the same for description, this will go sort of outside of that ng-if and access the controller scope. And again, the reason that ng-if broke it is that behind the scenes, ng-if is creating a new scope that inherits from the other scope, whereas ng-show does not. So if I change this to $parent and add an image, it should work. We should be able to see it. There we go. We have the image working again. But now my code is really brittle. So if I make just about any change to this code, it's going to break it. Like if I change this back to an ng-show or do anything else that changes how many scopes are being created, $parent is now no longer going to refer to the correct scope. So this is not a good way to solve the problem because, again, you're going to make some really seemingly unimportant change, like putting in an ng-if somewhere, and it's going to totally break your code. What you want to do is just have anything before the model that you're binding to. So if you're binding to any expression that has a dot in it, you're not going to run into this problem. Because essentially what's going to happen when you have an ng model like this is instead of just setting URL on the inner scope, first it's going to get test, which will be up on the parent scope, and then it'll set URL up there. So this is a really confusing problem, and it's not something you ever really have to think about if you just use the controller as syntax. So going back to the slides, the controller as syntax looks something like this. So here's my modal directive. Right now, I'm just using a link function. So I'm going to replace this link function with an actual controller so that I can use the controller as syntax. And it's going to look something like this. So now I have a controller, which lets me structure the controller a bit more. I don't just have to register all the functions in one method. So I can put things on the prototype of my controller. I can use this controller as, and that's going to give me a prefix I can use in my HTML so that I'm never binding directly to something on the scope. And it's also going to create a new instance of my controller. So instead of just calling this controller function, it's actually going to instantiate a new instance of it, which is why I can use the this keyword. And bind to controller is another really useful thing when you're using isolated scope, because what that'll do is it'll take those scope variables that are being passed in. So you know how in the last example we set up the show variable and this onSubmit to be passed in? It'll take those and put them onto your controller instead of just having them on the scope. And this essentially removes all need to ever use $scope. You can always just use your controller, which is much more in line with how things are going to work in Angular 2. In the HTML side of things, I'm going to need to go prefix everything on my controller with whatever my controller as string is, as you can see here. So first of all, why do we want to remove link functions and use controllers instead? Well, linking and controllers are kind of redundant concepts, and they're really confusing when you're first getting started with Angular to know when to use one and when to use the other. So whenever you have a directive that has a template, you can just use controllers, and you pretty much very rarely need to even think about link functions. And also using a controller lets you use the controller as syntax. So the controller as syntax is great because you don't have to worry about this weird scope inheritance problem anymore. You can have better organization. It worked really well with ES6 classes, as we'll see in a little bit. And it's essentially how components work in Angular 2. With the exception of, in the HTML, you don't need to prefix them with anything. But in your actual controller, or in your JavaScript, you are putting everything on this instead of any kind of $scope. Again, bind to controller is great because it removes the need to use $scope for everything, and $scope doesn't exist in Angular 2. And parent is terrible. It's going to make your code really brittle. Any changes you make are going to break it. It breaks encapsulation, so it makes it really hard to see what sort of side effects are happening and what state you actually rely on. It makes unit testing really hard. You really have to understand the intricacies of how scopes get created in Angular and how scope inheritance works. And it's not in Angular 2. So it's a really good one to avoid. In Angular 1.5, they introduced a new .component helper. So this is essentially just syntactic sugar for the .directive method that gives you much nicer syntax and has a lot of really useful default options. So if we take a look, I can replace all my .directives with a .component, but I'm also actually going to replace all my controllers with .component. So right now I'm registering image list as a controller. I could instead register it as a component, which is going to be pretty much the same. I just need to give it a template URL now. And I just renamed the controller to image list component instead of controller. But this is going to break my router, because my router is expecting there to be a controller registered somewhere. So if you take a look at the router, it's expecting image list controller to be a controller, obviously. But we can just replace it with this. So we actually just instantiate our directive. And now we can use components everywhere. We have removed the need to ever use .controller or ngController or router controllers or views or ngInclude. We can just consolidate all those concepts into this new .component method. So again, it's much nicer syntax than the .directive method. It gives you a lot of good default options like controller as by default, bind to controller by default, isolated scope by default. It just kind of helps to enforce a lot of these best practices. And again, also removes a lot of these redundant concepts that don't exist in Angular 2. And it's the syntax is quite similar to the way that you do components in Angular 2. And the actual semantics behind it is almost identical to how things work in Angular 2. All right, so TypeScript. Angular 2 is written in TypeScript, and it's sort of intended that you write client-side apps for it in TypeScript. You certainly don't need to, because at the end of the day, TypeScript just compiles down to JavaScript. But you get a lot of benefits from using Angular 2 if you're using TypeScript, and you also get a lot of benefits in Angular 1 if you use TypeScript. For example, TypeScript is a superset of ES6, essentially. So you can start using a lot of ES6 features. So right now, my controllers are registered like this, where I add things onto the prototype of the controller. I could write this with much nicer syntax in ES6 using an ES6 class. So it would just look like this, and I never have to write the word prototype again. It's just much cleaner. So I have a little example of using TypeScript. And essentially, all I've done here is renamed all my .js files to .ts. And that's really all you have to do to start using TypeScript, seeing as though it is just a superset of JavaScript. So if I take a look at the gulp file. So I had to create a gulp file now that I'm using TypeScript. It's just going to take all of the .ts files in source and compile them to ECMAScript 5 using this TypeScript compiler. So we can run it. Let's just run gulp. And text is a little small there. I don't know if you can see, but we're getting a bunch of errors. And most of them are around cannot find name Angular. Basically, TypeScript doesn't like it when you have global variables that it doesn't know about. It wants you to declare any global variables. And it also would be nice if we could get IntelliSense and autocomplete for everything around Angular. So there's a community library, or there's a community tool called TSD, and I can use this to install type definitions for Angular. So if I say TSD install -- save Angular, very similar to how you use NPM. It didn't actually create any files because I already had them, but what this would do is create you this typings folder and download this angular.d.ts for you. And this has all of the typings for Angular. So this will give you full autocomplete for everything in Angular. And also let the TypeScript compile time type checker find any errors you have using Angular. So in order to use these typings, I need to tell the TypeScript compiler that I have them. So right now I'm only compiling things in the source folder. So I want to also compile things in the typings folder. So let's start up TS. All right, so now I should be able to run gulp again, and it should have fixed most of those issues. Okay, so now I'm not getting any of those global Angular issues anymore, but I still am getting a couple errors. So they're in image editor modal component. So let's take a look at what's going on there. The first one you can see is underlined in red here. I'm assigning a string false to a variable instead of the actual Boolean value. But I haven't even added any type annotations to TypeScript yet. So how does it even know that this should be a Boolean? Well, it can basically infer types. So since I initialized this to a Boolean, it's going to assume that it's a Boolean, and it can catch this error I made where I'm setting it to a string. So I can fix that. The other error it's complaining about is on this line here. So it's complaining that this, this object I'm passing into .component is not the right type. And I can actually get autocomplete here and see all the different fields that I would be able to pass into .component. And you can see that scope is not one of them. So instead, when you're using .directive, you can use scope, but with .component, use bindings instead. So if I change this scope to bindings, now my TypeScript should stop complaining about those issues. And I can also get full documentation on this, on anything Angular, really. So if I go to the definition of component, I can see this function takes a string and these component options. And if I go to the component options, I can see, okay, it takes a controller that's a string or a function. It takes a controller as string, which defaults to $CTRL, and so on. So it really helps with, not having to go to the docs every time you need to check how to use something in Angular. And so I've already found quite a few bugs and haven't even started adding any type annotations. So if I do add some type annotations and give TypeScript a bit more to work with, so I say these are strings, this onSubmit is a function that takes an args parameter. Args is an object that has an image parameter or image field, and image is of type image. The syntax here is a little bit confusing, but basically image here is an interface that I've defined elsewhere. So if I go to the definition, you can see image here just has a URL and a description. So it just gives TypeScript a bit more to work with. And you can see it's already found an error here. Now that it knows that URL is a string, it knows what all the string methods are, and it sees that I spelt to lowercase wrong. So I can just fix that typo there. And it's still complaining about this line. It's basically, if I look at the compiler, it's going to tell me that this is not a valid image. And again, if I do autocomplete on an image, we see it has a description field and a URL field, but I'm passing it a text field. So we want to replace that with a description field, and now TypeScript should be happy. And it's kind of helped us track down quite a few bugs. So that's TypeScript. Now that we're using TypeScript, the .service help method in Angular is a lot more useful. Because with .service, you can use ES6 classes. So right now I have an API service that I'm defining using the Angular module .factory. So I'm just defining these two functions and returning an image or returning an object that has those two functions. With ES6 classes, I can instead use a service. So I can define this whole API service as a class and then register it with .service instead. And it's just a much nicer and cleaner syntax. And now I actually have a type for this API service that I can use to tell TypeScript what type a certain thing is and get autocomplete and have it catch errors for me. So using services is great with ES6 classes. Removes another redundant feature of Angular, whereas I pretty much never need to use .factory anymore. And this is very similar to how services work in Angular 2. In Angular 2, a service is basically just an ES6 class. So migrating this to Angular 2 is going to be completely trivial. Okay, SystemJS is a module loader for JavaScript. Up until this point, all these best practices I've been talking about, I would do regardless of whether I was planning on ever migrating to Angular 2 or not. SystemJS is a bit more, I'm a bit more on the fence about. It's really useful, but Angular 1 does already have its own module system. While it's not as powerful as a real module loader like SystemJS, it's a bit clunky when you're using both of them side by side. But SystemJS is really going to help with migrating to Angular 2. So basically what SystemJS will let me do is start using ES6 imports and exports for modules. So I have this class here for my image modal, and right now you can see I have all the metadata for it, and I'm just registering it as a component right in this same file. If I were to use SystemJS, instead of registering it all in this file, I would export these options that I want to use to register the file, or to register the component, and in my app.ts, I could register all my components through ES6 imports. So let's take a look at what that would look like. Another example here. Yes. Okay, so I changed a few things in this example. First of all, I added this module system to the TypeScript compiler args. So what this is doing is telling TypeScript to, whenever it sees any ES6 imports and exports, to treat these as a SystemJS module. There's a few different module systems you can use, like CommonJS or AMD. We're going to be using system. So now if I rerun gulp, we can take a look at what it's going to output when it compiles one of these. So if I open up my API service, here's what the TypeScript looks like. So I'm just exporting this class as the default export. And then what it's going to actually generate for us is basically wrapping all my code in a system.register call. And this is going to let system.js totally manage when this code is loaded in. So I'm no longer just running this code on the global scope. I'm going to have, if I want to use this code, I'm going to have to import it through system.js. So the first thing we're going to have to do to import it is add system.js to our index.html. And once I'm using system.js, I don't need to include any script tags for my files anymore. I'm just, instead of importing all my scripts through script tags, I'm going to import them through system.js, which will essentially import them through ES6 imports and exports. So I can remove all these script tags, and then I need to tell system.js to basically kick off the application by importing a module. So this line here, system.config, this is just saying that anything in the source directory I want to be able to import with the default file extension of JS. So instead of needing to say app.js, I can just say import app. And running system.import of app is actually going to load my app.js file over Ajax. And let's take a look at what app.ts is doing. So since I'm not registering any of my services or components anymore in the actual files that they're defined in, I need to do that all in this app.ts file. So it's going to look something like this. I'm going to register my API service, my image list, and my modal. But I'm getting errors right now because it doesn't know what API service is. I need to do an ES6 import in order to get this working. Thankfully, WebStorm will automatically do the imports for you, so I can just go and hit Alt-Enter over these, and it's automatically going to add all my import statements. So now that I've added these imports, this will actually cause SystemJS to go and load all those files, make Ajax requests for them, and import them into my app.ts. And the last thing you have to do is manually bootstrap your app. So instead of using ng-app to start off your app, you need to basically wait for SystemJS to be all ready and have already lazily loaded everything before you start your application. And we do that by just manually calling angular.bootstrap after SystemJS is done loading all my modules. All right, so SystemJS lets you use ES6 modules, which are great, and Angular 2 needs a module loader in order to work, so it's really going to help if you're planning on migrating to start using SystemJS now. So we've gotten pretty far into this without actually doing any migrating to Angular 2, and I think this really is the bulk of the work, is just adopting all these best practices, getting your Angular 1 looking like Angular 2 before you start actually trying to migrate it. Once you do want to migrate it, you can use this ng-upgrade library and actually bring in Angular 2. So you're going to need to add the following scripts to your index.html. These first four are just polyfills that it uses to make sure it works in old versions of IE and whatnot. Then I'm including rx.js. So this is a library for observables. If you're not familiar with observables, they're sort of like promises, but a lot more powerful. And whereas a promise can only resolve once, an observable can essentially have a whole stream of events that happens. And they're used in a lot of internal calls in Angular 2. So then I'm just including Angular 2. I'm including Angular 2's HTTP library. And then I'm including this upgrade adapter, which is what's going to let me run both Angular 1 and Angular 2 in the same app. I'm going to create an instance of this upgrade adapter and just export it from its own file, so I can now import this adapter variable into any file that I need to use the upgrade adapter in. And in my app.ts, instead of bootstrapping it with angular.bootstrap, I now need to give the app the adapter control over how the app gets bootstrapped. So I'm going to do adapter.bootstrap instead of angular.bootstrap. And in my gulp file, there's a few things I need to change to make this start working with Angular 2. First of all, I need to, where did my slide go? First of all, I need to include this browser.d.ts file. This is going to add a bunch of TypeScript type definitions for ES6 syntax that Angular 2 uses internally. And if you don't add this in, TypeScript's going to complain about a bunch of this new ES6 syntax. I'm also adding in this experimental decorators tag. What this does is it lets you use this proposed ES7 feature of decorators, which are kind of like annotations for JavaScript. And Angular 2 really heavily leverages decorators. And this other option I'm giving it, emit decorator metadata. What that'll do is it'll take anything that has a decorator on it and output the type information at runtime. So normally when TypeScript compiles your TypeScript files, it strips out all your type annotations. They're just used at compile time to help find errors. But when you put this emit decorator metadata on, it's actually going to output that type information so you could access it at runtime. And that's useful for Angular 2 because Angular 2 is going to use that information to do its dependency injection. So instead of in Angular 1 where you had to give it a list of strings that were all the names of things you wanted to dependency inject, in Angular 2, it'll just use the types that you're giving it in TypeScript to do dependency injection. And lastly, I'm adding this module resolution node flag. And what this is going to do is tell TypeScript to look in your node modules folder for TypeScript definitions. Since Angular 2 is written in TypeScript, they package all the TypeScript definitions along with their NPM module. So instead of needing to install things through TSD, like we were doing before, now it can just go and find everything in node modules automatically. Okay, so now we're actually ready to start upgrading parts of our app. So let's start off by just replacing the Angular 1 $HTTP service with Angular 2's new HTTP service. So the app is kind of laid out like this right now. We have an image list component, and it uses the image modal, and it also uses this API service. And the API service uses Angular 1's $HTTP. So if we upgrade, or if we want to start using the new version of HTTP, we're going to have to downgrade it into an Angular 1 service so that we can use it inside another Angular 1 service. So essentially, API service is an Angular 1 service, so it can only have Angular 1 services as inputs. So yeah, we're going to have to downgrade Angular's HTTP module. That would look something like this. So this is just how you start using Angular 2's HTTP. It's a little bit tricky to get started with Angular 2's HTTP service, as it requires a bit of configuration, but this is sort of what it looks like. So I'm calling adapter.addProvider. This registers not only the HTTP service, but a bunch of related services as Angular 2 services. And then I'm registering a Angular 1 service called HTTP by downgrading that Angular 2 service. I've also have this import here, rx/add/operator/map. Basically, Angular 2 returns you observables from a lot of different calls, but the RxJS library is huge and has a lot of different calls in it, so Angular 2 wants you to opt into any calls you actually want to use. So if I want to use this map function, I have to manually import it somewhere. Now, here's how I would rewrite my API service to use Angular 2's HTTP service. You can see I'm injecting it because it's named HTTP, and that's what I called it when I registered this HTTP service here. And now http.get returns me an observable instead of returning a promise. So in this simple example, they're pretty similar. I'm going to use .map instead of .then. And then when I call this, or whatever calls get images, is going to have to deal with observables instead of promises. So that would just look something like this. So instead of calling .then on the promise you get back from get images, you could call .subscribe, and that will essentially do the same thing for you. Okay, so that's all we really need to do to migrate, to start using this new Angular 2 service. What if we wanted to migrate our image list component over to Angular 2? So this is a really dumb idea. You really don't want to jump into the middle of your application and start upgrading things to Angular 2, because you're going to have to upgrade and downgrade everything that it touches. You kind of want to work in from the edges. So it would make more sense to migrate the API service or the image modal. But just so you can see all the different things the upgrade adapter can do, I'm going to do this the most complex way possible and upgrade image list first. So if I upgrade image list to an ng2 component, I'm going to need to downgrade it to use it in Angular 1's router, and I'm going to need to upgrade the two inputs it has. So you're going to end up with something that kind of looks like this, which looks a bit confusing, but again, I've now rewritten image list as Angular 2, so I need to downgrade it to have it work in the Angular 1 router, and these two inputs it has need to be upgraded so it can use them. And in this example here, you're seeing everything that the upgrade adapter can do. So it essentially only does these four things. It takes Angular 2 components and downgrades them, which you're seeing happening right here. It takes Angular 2 services and downgrades them, which is happening here. And then it takes Angular 1 services and upgrades them, which we're doing here. And it takes Angular 1 components and upgrades those. So once you can figure out how to do these four things, that's pretty much all you need to know in order to migrate an app. So let's take a look at how we would actually migrate, or how we would rewrite this image list component as an Angular 2 component. So here's how it's written right now in Angular 1. I have sort of all the metadata associated with it just in this variable that I'm exporting. So in Angular 2, I'm going to take all that metadata and put it in this component decorator. So this is the decorator we enabled with that TypeScript flag, enable experimental decorators. So you can see it's pretty much the same as before. The only difference is I now have to specify all the directives that this component uses. So I want to use the modal directive from my image list component, but it's an Angular 1 component, and my image list component is now an Angular 2 component. So I need to call adapter.upgradeNG1 component in order to use it here. Now in the markup for my image list, I need to start using the Angular 2 directives and template syntax instead of the Angular 1 template syntax. So instead of using something like ng-click, I'll use click now. Instead of using ng-repeat, I'll use ng-for. Down here, this is the syntax they use for a two-way binding, which is not really a two-way binding. It's sort of just some syntactic sugar for a two-way binding, because Angular doesn't really have two-way bindings. And I'll show an example of what I mean by that in just a second. In my app.ts, I now need to downgrade this image list component so that it can be used in the old Angular 1 router, and I need to upgrade the API service so that I can use it in this image list component that I've just rewritten in Angular 2. So yeah, that ends me up with something like this. Now we can start to simplify things. So let's migrate the image modal to Angular 2, which is going to end up with something like this. I won't need to be upgrading and downgrading so many things anymore. Here's how this looked in Angular 1. Again, we've got all of our metadata in this object here, which we're going to slap on a component decorator in Angular 2. But you can see the bindings are not in that decorator. So for the bindings, the inputs and outputs, I'm going to annotate fields on my class. So I can say the show boolean is an input, onSubmit is an output. And I was saying that Angular 2 doesn't really have two-way data binding. So you can see I can't say that something is both an input and an output. I need to explicitly have an input that is this boolean, and then I have a show change, which is my output. And Angular 2 just gives you some nice syntactic sugar to work with this as though it were a two-way binding, even though inside you can see I really have one thing that's an input, another thing that's an output. So if I want to change the show variable, I would say show change.emit, and then I would emit some value for it. Okay, let's upgrade the API service to Angular 2. So this is really going to simplify things. Once I upgrade API service, I can use HTTP directly, so I won't need to downgrade HTTP anymore. So I'll end up with something much simpler that looks like this. Upgrading a service to Angular 2 is pretty trivial. It pretty much already is an Angular 2 service. The only thing I have to do is add some decorator to it. So I'm adding this injectable to it, and that just enables dependency injection in Angular 2. Now I don't need to register the API service as an Angular 1 service anymore, because I'm only using it in Angular 2. And I don't need to downgrade HTTP, because now I can inject it directly into an Angular 2 component or service. To register this API service as an Angular 2 service, I just need to call adapter.addProvider. And that's literally all you have to do to migrate a service. So now we're getting to the point where we can just totally remove all references to Angular 1. The only thing I'm still using is the Angular 1 router. So I can replace this with an Angular 2 router. But the way things work in Angular 2 is that everything is just a component or a provider, which is what they call services now. So instead of having some root level special case for a router, I'm just going to have an app component in Angular 2. That'll look something like this. So you can see I'm creating this app class. I'm declaring it as a component, and I'm giving it some routing options. So it just has one route, which will go and load up the image list component. And once I've done this, I can now remove all my script tags importing Angular 1. I can remove the upgrade adapter and everything around that. And I finally have fully migrated this to Angular 2. So to sum it all up, Angular 2 is really just based on components and services. So if you can start writing your Angular 1 that way, it's really going to help when it comes time to migrate. You can migrate things incrementally. You don't have to just rewrite your whole app in Angular 2, which is just not really going to be feasible in a big application. And by following Angular best practices, it's really going to get you like 70% of the way there to migrating to Angular 2. That being said, you don't necessarily need to upgrade every single Angular 1 app to Angular 2. I mean, Angular 1 is a great framework. It's not getting any worse just because Angular 2 is around. And depending on your project and how long it's going to live and how long you're going to be working on it, it may or may not make sense for you to actually do the upgrade. So yeah, again, I'm Rob McDiarmid. I'll put the slides up on the FITC site. You can also grab them at this URL. You can hit me up on Twitter at RobbieandMcD. I work as a software architect at Conrad Group and teach some Angular for BrainStation. We're always looking for good people, so if you're looking for a job, let me know. I can put in a good word for you. And thanks for coming out.